Good day, everyone. I am Teacher Juno, and welcome to my class. For today's video, we will be discussing about the relationship between the coefficients and the roots of a quadratic equation, specifically the sum and product of the roots of a quadratic equation. But before we start our discussion, let me share with you the following objectives. First, to find the sum and the product of the roots of a quadratic equation using the values of a, b, and c. Second, to determine the quadratic equation whose roots are given. There are other interesting and useful relations between the coefficients and roots of quadratic equations. It is possible to determine the sum and product of the roots without solving a quadratic equation. How can the sum and product of the roots of the quadratic equation be obtained without solving the equation? If r sub 1 and r sub 2 are the roots of the quadratic equation ax squared plus bx plus c equals 0, wherein a is not equal to 0, then the sum is equal to negative b over a and the product is equal to c over a. Let us have some examples. For example number 1, we have x squared minus 6x plus 9 equals 0. First, we have to make sure that the quadratic equation is written in standard form. Then, identify the values of a, b, and c. For x squared minus 6x plus 9 equals 0, the value of a is equal to 1, b is equal to negative 6, and the value of c is equal to 9. To find the sum of the roots of the given quadratic equation, we will use the formula negative b over a. After identifying the values of a, b, and c, use the formula for the sum of the roots, which is negative b over a. Then, substitute the values of b and a to the given formula. We will have negative times negative 6 over 1, which is equal to positive 6. Therefore, the sum of the roots of quadratic x squared minus 6x plus 9 equals 0 is equal to positive 6. To find the product of the roots of the given quadratic equation, we will use the formula c over a. Substitute the value of c, which is 9, and the value of a, which is 1. So we will have 9 divided by 1 is equal to positive 9. Therefore, the product of the roots of quadratic equation x squared minus 6x plus 9 equals 0 is positive 9. Next example number 2, we have x squared plus 5x minus 14 equals 0. The value of a is equal to 1, the value of b is equal to 5, and the value of c is equal to negative 14. To find the sum of the roots of the given quadratic equation, we will be using the formula negative b over a. By substitution, we will have negative 5 divided by 1, that is equal to negative 5. So, the sum of the roots of quadratic x squared plus 5x minus 14 equals 0 is negative 5. For the product of the roots, we will be using the formula c over a. Substitute the value of c, which is negative 14, and the value of a, which is equal to 1. So we have negative 14 divided by 1, that is equal to negative 14. How about determining the quadratic equation whose roots are given? How can you obtain the quadratic equation if the two roots are known? When both sides of the standard form ax squared plus bx plus c equals 0 is divided by a, which is not equal to 0, then it becomes x squared plus b over ax plus c over a equals 0. The quadratic equation can then be written as x squared minus the sum of the roots of the given quadratic equation plus the product of the roots of the given quadratic equation equals 0. This relationship is useful in writing the quadratic equation whose roots are given. For example, what is the quadratic equation whose roots are positive 6 and negative 1? Using the given roots, find the sum and the product of the roots of the unknown quadratic equation. Then, substitute the sum and the product in the form x squared minus the sum of the roots x plus product of the roots is equal to 0. Since the roots are positive 6 and negative 1, therefore the sum of the roots is equal to 5. And for the product, it is equal to negative 6. After finding the sum and the product of the unknown quadratic equation, substitute them into the form x squared minus the sum of the roots, which is positive 5, x plus the product of the roots, which is negative 6, equals 0. Therefore, the unknown quadratic equation is equal to x squared minus 5x minus 6 equals 0. For example number 2, the sum of the roots of the quadratic equation is negative 5. If one of the roots is 2, how would you determine the equation? Write the equation. In example number 2, we are given one root which is equal to 2 and the sum of the roots which is equal to negative 5. So in order for us to find the product of the roots, we have to find the other root or solution of the unknown quadratic equation. So we just have to subtract positive 2 from negative 5. So we will have negative 5 minus 2, that is equal to negative 7. Negative 7 is the other root of the unknown quadratic equation. Then, for the product of the roots, we multiply positive 2 with negative 7, so the product is equal to negative 14. Then, substitute the value of the sum, which is negative 5, and the value of the product, which is negative 14, x squared minus sum of the roots x plus product of the roots equals 0. So therefore, we will have x squared minus negative 5x plus negative 14 equals 0. Therefore, the unknown quadratic equation in example number 2 is x squared plus 5x minus 14 equals 0. Now, it's your turn. You can pause the video and try to answer the following activity. Good luck! I know you can do it. For let's practice number 1, you are given m squared minus 8m equals negative 15. So you have to transform the given quadratic equation in standard form, identify the values of a, b, and c, and find for the sum and the product of the given quadratic equation. For number 2, determine the quadratic equation whose roots are 4 and negative 10. Alright, so let us check your answers. You can pause the video and check your answers. For number 1, The standard form is m squared minus 8m plus 15 equals 0. The value of a is equal to 1, b is equal to negative 8, and c is equal to positive 15. The sum of the roots of m squared minus 8m plus 15 equals 0 is positive 8, and the product of the roots is equal to positive 15. For let's practice number 2, the answer is x squared plus 6x minus 40 equals 0. Thank you for watching and happy learning!